Hello and welcome to Scale Drawings Review Lesson 2. Today we're going to find a scale model measurement. And after yesterday's lesson, everything will be very similar except for the operation we use. In our previous lesson, we discussed how to find the measurement of an actual object given the scale, what one measurement on a model represents on the actual object. We also looked at 3 different methods to accomplish this. Today we will discuss how to find a measurement on the scale model or scale drawing if we are given the actual measurement of the object. Finally, we will discuss how to find the scale factor, which is also the unit rate, if we are given measurements of both the model and the actual object. So let's get going. A model statue has a scale of 3 centimeters to 21 meters. If the real statue is 14 meters tall, then how tall is the model of the statue? And you're going to notice these 2 dots. That's another way that a ratio is written with these 2 dots. So first of all, we're going to use our method 1. We're going to use a proportion to set up the first one. And just like we did last time, we're going to just use it in order that they gave it to us. 3 centimeters over 21 meters. That's the scale that they give us. And we're being asked now to find how tall the model is. So the model is in centimeters. They also mentioned that the real statue is 15 meters tall. So this time we're going to put our x centimeters. We don't know the model measurement, but we do know that the actual, is 14 meters. So now everything's right with our proportion. We're going to cross multiply using the butterfly method. And we will get 3 times 14, which is 42. And that's going to equal 21x. Now in this particular case, we have to solve for x, which means we're going to divide by 21 on both sides of the equation. And we're going to get 2 equals x. So what exactly does that mean? Well, if we look right here, x is centimeters, and so the model is 2 centimeters tall. All right, so now let's try the second method. And the second method is the chart method, and we start that by finding the ratio of the actual object to the scale object, and we get 7. This is what we're going to call our rate, and we're going to use this number in a minute. So the chart method will put all the centimeters on one side, the first side, and the meters on the second side, and they've given us 3 centimeters and 21 meters to start with. But they also gave us the actual statue. So they've given us 14, and we need to now move this direction in order to figure out what the centimeters are. So we're going to divide by 7. This 7, that's where that comes into play, divide by 7. And we would get 2. And just like the first method, that means that our model is 2 centimeters tall. So now let's look at our third method. The third method uses an equation, and that equation is the rate times the model equals the actual. And we've already figured out the rate from the previous method. So the rate is 7, the model we don't know, and the actual object they told us is 14 centimeters. So we're going to divide by 7 and divide by 7. So our model is 2 centimeters tall. And you're going to notice on every single one of these, we had to divide in order to find the actual object. So let's try one more practice problem. A map uses a scale of 1 5/10 inches equals 60 miles. If the distance between Buffalo and Albany is 290 miles, what is the scale distance on the map? So we'll start once again with our proportional method. And when we do this, we use, and we don't have to, but I usually start with the scale as it's given. You could reverse them if that makes it more comfortable and more consistent for you. Just be sure to label the inches and whatever the other measurement is. In this case, it's miles. So that's what they've given us. They've told us that this is the scale. They also mentioned that the distance is 290 miles. And they're asking us what is the scale difference. So we don't know the scale difference. So we know it is in inches, but we do know the actual miles are 290 miles. So once again, we're going to cross multiply. And when we do, we get 60 miles times x, and then we get 435. So we're in a situation now that we need to divide on both sides, and x equals 7.25, or we could call this 7 1/4. So what do we find again? We found that the model distance is 6 25 inches, or if we're measuring inches, we'd probably say 6 1/4 inches. So now let's move on to the chart method. So we start that by taking the actual, which is 60 miles, over the scale, which is 1 5/10 inches, to get our unit rate, which is 40. Now we're going to build the model, and our model is inches, our real is miles, and the scale they gave us, if it helps you to put this in the chart, that's fine. Whoops, it should be 60. And so what they've given us is 290 in miles. But since we're going backwards, so to speak, we want to divide by our rate. This is our rate. So we're going to divide by 40. And we'd once again get 7 25, or we would say that this is 7 1/4 inches. And I forgot to put my scale over here. So our very last method would be the equation. And our equation is the rate, which is the unit rate, same as we used in method 2, times the model dimensions, and that's going to give us the actual dimensions. So the rate was 40, the model, we don't know, and the actual was 290. So just like in the proportion method, we're going to divide both sides, this time by 40, and we're going to get that our measurement, our scale measurement, is 7 25, or 7 1/4 inches. All right, so let's move on to one more skill. So now we're going to find the scale factor. Sometimes they don't give us the actual scale, but they do tell us one of the model dimensions and one of the real dimensions. And from that, we're going to be able to figure out the scale. The scale factor is also known as the unit rate, which we've talked about a couple times. So in this problem, it says a man in a photograph is 2 centimeters tall. His actual height is 1 8/10 meters. What is the scale factor? So let's highlight what important information is. Okay, so 2 centimeters tall, that is a photograph, so a model, and the actual height is 1 8/10 meters. And because we're looking for the rate, we're going to start this by putting the real, the actual, over the centimeters. Now, we could actually form a proportion out of this if you remember that the unit rate is actually the amount of one quantity for one of the other. So we're trying to figure out the number of meters for 1 centimeter. So this would be a way, if you're a proportion builder and you like that method best, you could still use proportion to figure this out. So when we cross multiply, we would have 2x equals 1 and 8/10, and we would get x equals 0 and 9/10. Now, the advantage of this, if I look back up here, here's my x, and I know that it's talking about meters. So what this means is that 1 centimeter equals 0 and 9/10 meters. So that's one advantage, is now we have our labels. However, there's a shortcut, and we've used it several times when we talked about the rate on the other two methods. And we start again with the real divided by the model. And when we do, we're going to go right to the answer. So this would be 0 and 9/10. And the meaning of that is 0 and 9/10 for every centimeter that we measure on the model. All right, one more example, and then we're finished. If you would like to pause this and try this one on your own, that's great. For those of you who'd rather not, we'll just finish it up. An 84-foot long driveway is just 7 inches on a scale drawing. What is the scale factor for this model? So let's highlight what we need. We need to know what the real and what the model is. And we're going to start with our real. If you're a proportion builder, we're trying to figure out how many feet for 1 inch. If you're not, you're just going to go directly to dividing the feet by the inches to get the scale. So when I cross multiply, I'm going to get 7x equals 84. I'm going to divide by 7, and you can see why we can go to the shortcut, and we will get 12. The nice thing, I know what 12 means. It means 12 feet. So 1 inch on the scale equals, on the scale model, represents 12 feet on the real. The rate that I would use in my equation would be 7. Thanks for watching. If you want to try the practice sheet, that would be wonderful. See you next time.